So suppose we're asked to classify these quadratic forms. Okay? So the very first step will be for us to write them as X transpose matrix X. Remember that the diagonal terms are easy. Okay? The off-diagonal ones are also easy, but you have to divide by 2. All right? So, we're not asked to actually remove the cross terms in these examples. We're just asked to classify. So we don't need to know the eigenvalues. We just need to know, are they both positive? Are they both negative? Is one negative and the other one 0? Is one positive and the other one 0? Or is one positive and the other negative? For higher dimensional matrices, this can be a more significantly more complicated question. But for 2 by 2, I've only got 2 eigenvalues. So we can take advantage of something. If the eigenvalues have the same sign, then their product is positive. If the eigenvalues have different sign, then their product is negative. If one of the eigenvalues, or both, is 0, then their product is 0. We can take advantage of that because the product of the eigenvalues is immediately accessible via the determinant. The determinant is negative, therefore the eigenvalues have distinct sign. One's positive, the other one's negative. So this quadratic form is indefinite. Let's do the next one. All right. The determinant is 6. All right? That means that the 2 eigenvalues have the same sign. It does not mean that they're positive. It means that they have the same sign. In order to determine that sign, we can look at the trace. The trace is the sum of the eigenvalues. So I have 2 eigenvalues. All right? They have the same sign, but their sum is negative. Well, then both of them must be negative. So this quadratic form would be negative definite. How about this last one? There's my matrix. The determinant is 3 minus 81/4, which is clearly negative. So we would have an indefinite quadratic form. Let's do another one real quick. What if instead, let's see. Now I wanted to change this one, I think. What if instead it had been this? All right? In this case, I would have 4, 2, 2, 1. Now the determinant is 0. So it's going to be one of the two semi-definites. The trace is 5. So, one of the eigenvalues is 0. The sum of the eigenvalues is 5. Okay, so the other eigenvalue must be 5. But what we care about here is that it's positive. So this is going to be a positive semi-definite.